In this video, I'd like to go over making injection mold design guides for FreeCAD and what tools that FreeCAD has that allows you to produce a good injection molded part. This is specifically for rib design, and I think I'll come out with other videos in the future like gussets or bosses or all sorts of things. But as of right now, I want to cover an example part that utilizes a lot of support ribs. Let's create a part. Also, I'd like to feature Allvisuals4u, who will be covering easy ways to make injection molded cavities. So if we come through here and do symmetry, we'll go horizontal, something like, let's say 5 inches. We'll go vertical. Notice I have my keyboard monitor down here so you can see what hotkeys I use. Something like 3 inches. I'll make it bigger, 7. That's great. Now I can close and extrude this. And in this video, I'd like to go over making injection mold design guides for FreeCAD and what tools that FreeCAD has that allows you to produce a good injection molded part. This is specifically for rib design, and I think I'll come out with other videos in the future like gussets or bosses or all sorts of things. But as of right now, I want to cover an example part that utilizes a lot of support ribs. Let's create a part. Also, I'd like to feature Allvisuals4u, who will be covering easy ways to make injection molded cavities. So if we come through here and do symmetry, we'll go horizontal, something like, let's say 5 inches. We'll go vertical. Notice I have my keyboard monitor down here so you can see what hotkeys I use. Something like 3 inches. I'll make it bigger, 7. That's great. Now I can close and extrude this. And let's do something like 1.25 inches. Now I'll highlight this face and add a thickness, right? So we kind of thin this out, 0.125 inches. This seems to have defaulted to thou. I'm going to make the thickness on the inside. And okay, right? So we have like a shell or a main wall that we're going to put features in. The features, especially the ribs, are going to be dictated by the thickness of the wall, and that's very important. That's how you prevent sinks and voids, is by being cognizant of such things. I'm going to make a sketch on the inside, and I'm going to make a generic boss. And we'll give this a vertical dimension of 2 inches and a horizontal dimension here of, I guess you have to be negative 0.75 inches. I'm going to up that to -1, or down that to -1, depending on how you look at it. I'm going to give this a radius of 1/4 inch, and we'll give this a radius of 1/4 inch plus, let's say, 1 time my wall thickness. So, right, there we go. And there we have a boss. We're going to close that, and that's going to be a thick boss. I would expect some sink from that boss. Let's go with 0.75, right? So now let's say we have a boss and we want ribs to support this. How do I make ribs? At least ribs that I can be confident in. Well, the first thing is I'm going to import something so I can reference the center. And let's say I want to make my first rib, and ask myself, how thick do I want this rib to be, right? I'll constrain this rib here and here. And the rule about, and if you need to see, I'll go to wireframe so you can see more clearly. The rule about rib thickness is it depends on the material. And it's not too hard. You just have to know if you're working with a semi-crystalline or amorphous material. Amorphous materials will be 3/4 of your wall thickness max. Semi-crystalline materials will be half your wall thickness max. So I'm going to give this the max thickness, assuming I'm working with a semi-crystalline, of 0.125 inches. We'll get rid of thou. And we're going to say times 0.5. Right? So that's half my wall thickness. And let's do the same thing over here. Oops, but I want a rectangle. And we're going to make this coincident and vertical and equal. Right? So these lines are equal. That way with the design intent they can change thickness together if that gets updated. And let's extrude that. So we're going to say tasks, close, we're going to extrude. And then the next question is, how high should ribs be? Not dependent on your material. A rib should be 2.5 times your wall thickness. Max, right? So that's as tall as the ribs can be and still have some certainty that they won't start voids, sinks, ejection issues, or anything else. Now let's say I want to have a circular rib to help reinforce these ribs. I'll change my draw style, choose this face, and create a sketch. I'll again import this edge. And for visuals, I can go back to my wireframe view. And let's create another set of ribs that are circular to support the flex on these ribs. We'll give this a radius of 0.75. And give this another radius of 0.75 plus, and then 0.125 times 0.5. And there goes my circular rib. And we can extrude that. And we'll do the same, 0.125 times 2.5. Going back to our shaded view, that everything looks pretty good. Let's choose this face to sketch on again, and I'd like to add just a few more features. So we'll go back to wireframe. I'm going to use my edge import and import here, here, and we already have our circle center. So we'll just continue on these ribs on the other side of this boss. And actually I'd like to import this edge for some relations. We'll go coincident, coincident, and coincident. And we'll say how about 0.125 times 0.5. Right, that'll keep it an equal thickness to our other ribs. And I did not mean to exit the sketch there. So that seems relatively constrained. We'll go coincident, 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 and equal with the E key. Great. There is one problem that I'm seeing. I need to get rid of this coincident. I'm going to leave a little gap the way that I have it constrained now. So I'll get rid of this, and let me import another edge here. So I'll make it coincident to this outside edge, which is much more effective. My mistake there. In fact, I better choose. Sorry, a little bit tricky here. Here and here, coincident. There we go. Now we should be good to go. Let's close, tasks, pad, and I know it's giving us the same height as before, but I'm a creature of habit. 0.125 times 2.5. So there we have a set of support ribs on this boss. And people break these injection mold rules all the time, right? They can make ribs taller or wider or whatever, and it can work, but these are just the guidelines for being ideal. So I've got this little rib system. And how far apart should my ribs be if I've got parallel ribs? They should be 3 times your wall thickness at a minimum. Any tighter than that, and you're going to get more sinks, more voids, and ejection issues, probably. So keep that in mind. 4-way intersections between ribs. So here I've got a 4-way intersection. This increases the risk of sink, so that's something that you need to know going in. And I notice I have my ribs connected to my sidewall. That's a double-edged sword. I can stop my rib short of my sidewall and not connect it, and the advantages of that are I get less sinks and void risk and less risk of weld lines. But the pros of connecting the vent or the rib into the sidewall is I get better venting, better rigidity in the part, and it can even eject a little bit better. So keep that in mind. Now, what should I do for draft? Because draft is absolutely vital. My suggestion is to add draft and then add fillets, because in injection molding it is fillets, fillets, fillets. You do not want sharp edges in these parts. So make sure that you add fillets everywhere to avoid stress concentrations. But first, let's add draft. And for this, FreeCAD has an absolutely brilliant tool that I'm very impressed with, the Draft on Face tool. So if I choose this face and choose Draft on Face, I want to, I chose chamfer, whoops, this face and Draft on Face, there we go. I want to choose a neutral plane, and I have a Draft on Face tutorial that you can check out, but I choose a neutral plane here, and that specifies that this highlighted plane does not change dimensions, and so the draft is relative to that plane. I can reverse my pull direction, and you can see that anything on this plane doesn't change, it's everything else that changes. I'm going to draft this way, of course, and you think, how much should I draft a rib? And the guidelines are generally 1/4 of a degree to 3 degrees. 1.5 seems like a nice nominal amount, so I'm going to leave that there. And let's add another face here. And you can see it seems to know exactly how to draft it. So let's add another face, right? And we're just going to draft all the way around our part, all of our ribs. Add face here. And we'll add another face here. Add a face here. Add a face here. Add a face here. Add face here. Whoop. There we go. Add a face here. Add a face here. Alright, so all of my rib faces should be highlighted by the time I'm done. Alright, fantastic. Now, I probably want to do this boss. I'll put some more draft on this boss here. So I'm going to say OK on that. We're going to select this boss's face, add a new draft, and this time I'm going to specify 3 degrees of draft with a neutral plane here. Reverse pull direction. And that's pretty severe. Let's go 2 degrees, and I'm also going to add this face, right? So we're all drafted, and you can see the beautiful graphics on FreeCAD that they can show you that the ribs are wider at the bottom than the top, all of them, right? This is a beautiful part for injection molding. So we're going to say OK on that. Now, we also want to draft our outer wall. So it's a separate draft. And I like doing these separately because now I can change the draft angle on all features in a group instead of the part entirely, but I can choose a face, add a draft, specify my neutral plane as being here, reverse pull direction, I think 1.5 degrees is just fine. We'll add a face here, add a face here. All right, we're just going to go all around, add a draft to all these faces. So we should be able to see that all of these somewhat vertical walls have a draft on them. That's for good form on injection molding. Now, for fillets, rib intersections should have a fillet between the intersecting ribs, and that should be about a quarter of the thickness of your wall. So anytime ribs intersect, I should have a fillet that's about a quarter of the wall thickness, and you might be able to get it with 0.1 to 0.25 of your wall thickness. And I'm going to add that to the bases and tops of the ribs as well, because everywhere needs a fillet. Before I add these fillets, let's make this a little bit more interesting and start patterning this. So I'm going to choose multi-pattern, and I'm going to start with my pad, 001. We're going to add a mirror transformation here, and then a mirror transformation here, right? And we might have a problem with that circular rib. I can't tell if it's going to cross the halfway point or not. Let's add in another multi-pattern for this. Add a mirror transformation there. That looks pretty good. And we're going to add another mirror transformation on our XZ plane, right? So we're sharing these ribs. Then we're going to add another multi-transform on pad 003. Add a mirror transformation. And nope, looks like we're fine. So add a feature there, and then add a mirror transformation across my XZ plane. And you'll notice as I pattern these, if I go to my top view, there's no draft, right? So it patterns the feature, it does not pattern the draft. That's just fine. I'll add the draft in, and I won't make you sit through me adding the draft in. The last thing I'm going to do is multi-pattern pad 4. We're going to add a mirror transformation, and there it mirrored nicely. Add mirror transformation across the XZ plane. And there we go. So there we have that. I'm going to go ahead and in fast mode do the same draft that I just did on all the other faces, so you don't have to sit through it. Keep in mind, if you don't feel like doing this, this part is downloadable. The link should be in the description. Here we go. Alright, now that we've done that, everything is drafted, but of course you need fillets, 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 fillets. So again, we're going to start with some radii. Oh, I need to select an edge, so we'll go here, radius, and we're going to say 0.125 times 0.25, and instead of thou, we're going to make that inches. And there we have a fillet. So we're going to edit this fillet, and we're going to add in all of the edges where ribs intersect. There I selected a face. Faces do speed up your process. I like having the control of selecting a fillet at a time. So I won't make you sit through all this, but you can see how I add these fillets. Let's fast forward and save you some time watching this. Okay, so you'll see here that I've run into a little bit of a problem. This is filleting just fine over here, and this is not filleting okay over here. Well, what I'm seeing is there's a gap. So what has happened is, as we applied the draft feature, it pulled this rib over to continue the rib as it should have. But since I patterned the original feature, that did not work. So I need to make a quick edit. Let me make sure I've got the right pad. Next we take pad 002, we're going to edit the sketch. I want to go back into my wireframe, and if I delete this, I should be able to up this rib here. We're going to make that horizontal, and instead I'm going to just get this rib right in the middle so that nothing will interfere with the inside or the outside when we apply draft and then pattern. Alright, so we're going to make these parallel and equal. And now I can make this horizontal, and that kind of marks dead center. Likewise over here, we can get rid of this vertical, and I can choose one edge and mark the center over here with a vertical relation. And it might take a minute to rebuild since we have a lot of features that have come after this. There we go. That rebuilt pretty quick actually. We do have a broken feature. Looks like this draft is no good. So allow me to go back to this regular view as is. Let's get rid of this draft. Well, it looks like I have to add draft all over again, so I'm going to do that. I'm going to re-add the draft to the multi-transform since it broke, but now our fillets should be working very smoothly. I'll see you after adding draft. Okay, we're back. So again, I'm going to start adding the fillets now that I know that everything is kosher. And you've seen how I've added the fillets, so I'll go from that point. Okay, now I'm going to fillet around the base, and I won't make you sit through that because it's the same thing. Okay, I'm back, and you'll notice that there is a little bit of a bend happening in this boss, but that is simply a graphics error. That's not the actual model that we're looking at, so don't be intimidated. If I export this to a step file, which I'll pull up for you, you can see that all is well with our bosses, so don't be alarmed by a graphical error. It's totally fixed because it's not part of the B-rep body. It's just like a shading error or something. So this is the part that we've got. I'm just going to add some final fillets around the edge here. And if you've ever injection molded a box shape, you know that they always tend to bow inwards. So we'll just expect that if we actually injection mold this, which we won't because that'd be way expensive. See you in a second. Okay, so we have not a single sharp edge on the entire model now, and our walls are at a relatively constant thickness. So those are both very important for injection molding. Another question is how to make a mold cavity. So I'm going to turn this over to Allvisuals4u, who can make a mold cavity on this part, and show you some pretty easy ways to determine parting line and a few other things. Before I do that, why don't we take a quick analysis to see how this thing is going to fill and work. And while we're at it, why don't we also see what a bad example looks like of one that doesn't follow the rules. Here we are in an analysis environment, and I'm going to go ahead and load some flow results on this. All right, and with these loaded, if we take a look at fill time, and let's just observe how this thing is going to fill up. As we mold from the center, you can see these ribs are filling up very quickly and very nicely. The flow front is not really hesitating in this simulation. And we're able to flow with pretty good consistency all around. And if we look at our ribs, between recording and running this, I think my screen is a little bit blocky here, but if I look at flow front central temperature, we're at a rather even temperature throughout. Looks like that's not too bad. So if I change this to say an example that is not very good, right? A purposefully bad example. So this is kind of like what not to do. And if I load some results, you can see that I've broken several rules. I've made the ribs too tall and also too thin. All right, so here's an example of something that is totally not right to do. You can tell I intentionally made these ribs too thin and too tall. And let's see how that affects an injection mold already. And you can kind of tell by looking at the color, if this is a time scale, that something is already very wrong with these ribs. So if I play this animation, you can see that as we're filling up, the flow front seems to slow down right around here. We call this flow front hesitation. And because this cavity isn't filling all the way, you could technically think of that as short shot. But what's interesting is as everything else gets filled up, then the very last thing to get full are these rib features. So you have plastic that does not flow well because the rib is too thin, so we don't flow very well right here. And we end up freezing, right? The plastic ends up hardening, and we can't fill it the rest of the way. This is a little bit more thick and flows a little bit better, so we can fill up this center area. But again, we get flow front hesitation and largely stop off. And then finally, the last flow front kind of comes up from the back and fills everything else up the rest of the way. That is horrible. That is truly a failed fill. You don't want to have this kind of hardening and then go back and fill over it. It's just not right. So this is a failed mold, and this is an example of what can happen when you don't follow the rules. Nonetheless, people break the rules all the time and are successful, but keep in mind that there are different compromises you have to make, whether it be the quality of the fill, the ejection, the warp afterwards, the sinks, voids, lots of things to consider, so be very careful when deviating from an ideal design. I hope this video was helpful. I'm going to turn the time over to Allvisuals4u, and my partner channel is going to be covering ways to make cavities that can be filled. I'm going to put a link to Allvisuals4u video in the description. Go ahead and take a look at it when it gets uploaded, and I'll see you in the next video.